Welcome to Practical Python. I just want to say that I warned you with the title. I'm Jeremy Reichman, and I'm okay. If you haven't seen me in a while, this is not my disability beard. But I did create a survey for all of you at the conference, and I would love if you would take some time to fill it out if you haven't already. If you have, awesome. And here's a QR code and a link you can use to get to that survey. While it's on the screen, I'll tell you a little bit about what led me to this talk. And I've been using Python since about 2005, and I've really enjoyed it during that time. I got into it because it had readable code. I was coming off of taking a class on Perl, so you can see where I was coming from. I liked the clean code that I got out of Python with the white space. I actually liked that a lot. Even though it did, like with everyone else, cause a little bit of frustration in the beginning. I like not having to use a lot of semicolons. And frankly, handling strings and path names in shell scripts just terrifies me. And I really thought that Python worked well for me on that, from that standpoint. So fast forward to the last year here, and I became a Python Software Foundation contributing member. It sounds really cool, but it only takes a donation. So I was also trying to go to PyCon 2019 in Cleveland. I was really excited to check out that conference for the first time. And I don't think I've ever been to Cleveland either. But it's sold out. So I'm a really big fan of Jim Rispin, so can you all join with me and say this? I know you're not going to, but can you please? That sucks. That sucks big time. Thank you. I got permission from Jim to do this. You may notice that this presentation is not the typical kind of keynote presentation. I was really trying to get into some new things this year. So this is in Jupyter Notebook. Yeah. At least when I was doing this, I thought this was a great time to try out Jupyter Notebook, if only to avoid keynote integrity protection. I mean, this user approval stuff is getting out of hand, don't you think? I mean, it's more every year. Speaking of which, what's up with Apple design lately? I mean, do they really need to ship every laptop with a toilet seat cover? So why might you want to use Python, especially to access and process data on macOS? Well, there's a lot going on with Python in the data science world, machine learning, places like that. So that's a really big reason to look at the language if you haven't before. And I think this gives us all opportunities beyond macOS admin because, you know, eventually we may just all be doing everything with an MDM. And if you're doing Python, they might let you keep your Mac instead of giving you an iPad Pro. You may have heard that there's some changes coming this year to Python on the Mac. JetBrains posted some survey information about Python development in general. And using the power of Jupyter Notebook, I'm going to show you some text. And I'll calculate with this text and display a graph of some of JetBrains' figures. Pretty impressive so far, right? So taking some of the values that I got out of their survey, setting up some labels for Python 2 and 3, and some size values, and I'm going to make a pie chart, so I'm going to explode the pie chart. It's going to be cool. There. This is calculated real time in Jupyter Notebook. So it used the matplotlib module to generate this graph. So you can see that Python 2 only has 13% of developers using it anymore. I think that might be largely all of us Mac admins. Everybody else has moved on. So it's coming to be the end of Python 2. There's going to be no more updates, even for security, as of January 2020. So it's been good to Mac admins in this time. We've been using it for a decade or more, definitely more than a decade. But now it's time we had its funeral. so I came prepared. I know it's not as good as the casket that Mac OS 9 got many years ago, but I had a much smaller budget. So we have some decisions to make and some potential projects to convert to Python 3. Spoiler alert, we're in the end game now. The kind of end game where APNS particles let you go back in time through a quantum web proxy tunnel, configured with a pack file, of course, to bring MDM to the present. Got no laughs at all. I don't know, the script may need some work. So why you might want to use Python. First of all, it's probably good at this point to avoid Python 2. And we should look at the information in the scripting languages runtime section of the Catalina beta release notes. Python 2, though, is still in macOS today and for the very near term, but given the deadlines that we have, we shouldn't really depend upon it. After all, it's an older version of the language now. It has some Mac-specific features with PyObc, but it definitely has a harder and harder time every year communicating securely with things on the internet, with the changes to TLS and certificates that have been happening. And that's been a big drawback for a lot of our uses. So if you're using Python 2 for development on the Mac in 2019, you might think of this as the year of bridging dangerously. In the future, we will need to install Python in order to use it. It won't be available in every situation we've used and used it to manage Macs in the past, and we have to think of alternative strategies for various situations, like installer scripts. This is going to be pretty rough on us over the next couple of months and years. The group that met last night about Python 3 was talking a lot about this, and it's an ongoing conversation about when we can even get Python installed during deployment. We also have to think about Swift and Swift UI and where Apple's going with that, and the place of those technologies in Apple platforms. But there, as we were talking about in the Python meeting last night, there's some drawbacks to Swift in this situation as well. So I'm delighted to show you Python 3 today. It's the next evolution of Python. They redesigned the entire language, and they did it way back in 2008. That was when WWDC still had an enterprise IT track. Modern Python has dark mode support. Yeah, you may not realize it, but Python has had this support all along. You can enable this by selecting a theme in the terminal. And developers have taken advantage of this in their own coding environments and alternative terminals. They do the same kind of thing. ZSH, it's the new default shell coming to macOS, also supports it. And you can get a preview of that in the latest releases of macOS Mojave. There's even a Pro theme. It's called Pro in terminal, right from the Pro workflow team, I think. So, and these features are available today. Even better, there's sign-in with Python 3. After all, Python is way easier than remembering passwords for everything. And once you've signed into Python, you can do awesome stuff, like run Python. So how do you get started using modern Python, Python 3 on macOS? You go to python.org, download it, and install it. It's pretty complex. There's also an auto package recipe, so you can use that if you want. I've used it, it's pretty cool. This version of Python is a good choice for system scripting, fits right in the OS. It's especially good when coupled with Greg Niggles' relocatable Python framework, which lets you make a Python framework build that includes PyObc and some other modules that are helpful for Mac admin tasks. And it could be used to embed Python in applications as well. So Python 3 is already up to version 3.7, and 3.8 is on the way pretty soon. Just by rounding, we're going to get to 4. Beyond that, we can also install Anaconda as a distribution for Python 3. Can I get a show of hands how many people have had to install Anaconda for their users? How many people enjoyed it? All right. I actually have come to like it a little bit more because I'm actually using it for this talk. I'm running in Anaconda right now with Python 3. So that brings me back to my talk about Jupyter Notebook. I decided that I wanted to learn how to use this tool because I had heard vaguely that it could be used to run Python code, and I thought, wouldn't it be cool to have an entire 75-minute presentation that was all demo? It's really not that cool, but you know, it does run Python code live, and it can be used to give presentations. So I thought I'd try it out. But in doing so, I gave up on all modern presentation conveniences, things like drag and drop, easy editing, knowing what I was doing, animations, builds, and magic move. I don't know if you've seen my past presentations, but I really like the magic move. So I wasn't really sure if it was 20 minutes into the future or what. You don't know how hard it is to get graphics into this thing. I had to resign myself to troubleshooting my presentation environment. Like about 2 hours ago, it was breaking again. So that was really fun. Sorry, the cursor's very small.
This business will get out of control. It'll get out of control and we'll be lucky to live through it.
So that is what it kind of feels like to build your first presentation in Jupyter Notebook. So Jupyter assumes that every slide that you're making can have code on it. They actually call them cells in Jupyter, and you put code on them, and it's kind of by some extra development that you can actually use it for a presentation. That code executes somewhere, and that's wherever the kernel is running. So it's kind of an interesting architecture. The notebook is the data file on disk. So I'm running a notebook right now. That notebook stores the presentation, and I also have some other local files that I can use for images and so on, movies like Hunt for Red October, and I can reference those with the local file paths or a URL. The notebook server is a web application that hosts the notebook file. That server is also running on my Mac, but they don't necessarily have to be running in the same place. You can actually separate these things out and run things remotely. So it can be used to do that, but I had so much trouble figuring out how to run it in one place that I didn't really get into it. My web browser, in this case Safari, connects to that local notebook server and displays the outcome of the code and the markdown and all the other things that I've included in the talk. So it's running in an extension called Rise, which is very similar to, or which is using reveal.js, if you're interested in that. So this all provides for some interesting interactivity because you can literally run the code live in front of people. So this is going to be fun. For example, you can see the output of a path variable. Here I'm shelling out by using the exclamation point. Okay, that's my first verbal typo, so I need a drink. So there's my path. This is actually the path on Microsoft Azure notebooks. There's lots of different free Jupyter Notebook hosting services, and Microsoft and Google and some others have them available. I tried Azure because I like saying that word. I can also run the conda command, which is a command for managing Anaconda itself, its environments, and what modules are installed for Python. In this case, I'm running conda env list. I'm listing the environments that are available. If anybody's familiar with Python virtual environments, that's what conda is setting up. So I have a virtual environment set up specifically for this talk that I have specific modules and other things installed in. The base environment is the one that comes right from Anaconda itself. And the strange name, Anaconda 3 _ 501, in case you're wondering, because I don't want to have to throw this catch box, down from this elevated podium that I'm on. That name came from the Microsoft Azure Notebook service. They had some predefined environments set up, and it took me a long time to figure out how to use those, so I just kept using the names all the way through. I can also shell out and use the type command to find where pip is. If you're familiar with Python at all, pip is what we would often use to install packages. Even in an Anaconda environment, you can also use pip. And I've used the conda command here to list out the modules and versions that I have installed. And this is a scrolling list. Amazing, isn't it? So I said I could run code. Here I'm showing that I can run code. With the Jupyter Notebook presenter mode, I've found that if I type on my screen, you don't necessarily see my changes. So I'm going to try this over here, looking at the confidence display, and I hope it gives me confidence in my calculation. So what number should I pick? Throw one out. Somebody throw a number. 42. All right, I heard that first. So the weird thing is I'm typing down here and I don't see it on my screen, so the confidence is really gone. So there, that's running live Python 3 on my computer, going to the kernel that's running on my computer. So it can do more complex things than this. This is one of them. Here I'm importing some widgets that come from the IPython project. They're built into the Anaconda environment, because Anaconda has a bunch of things built in. And I can just drag this. Okay, this is going to happen. I'm going to go over to here again. Hold on. I can just drag this other slider on the other screen, and you can see that the number below is changing. It's actually running that function live. So, kind of neat. I'd never seen Python do that before. So, and it can also do things like this. Yes, there's a PyJokes module, and you would have expected that I would find it. So you can do something like this. A nice little VI joke. And I'm going to really tempt things, and I'm going to try to run this again and see what joke we get. There's some really weird ones. Oh, great. All right, so this is where I get to demonstrate something I just found out about. There's a keyboard shortcut to go backwards. I'm going to re-import this module. Yeah, this happens too. So I'm going to select this cell. I'm going to re-import that. Let's see if this will actually get this to work. If it doesn't, that's going to make it hard for the later ones. There we go. Completely different joke. If you need to leave now because you're so excited, feel free. So how did I do this? This is a really good question because I didn't keep track of my shell history for a lot of this, and so I'm kind of guessing on some of it, and I tried to set it up on the notebook that had the new toilet seat cover, but to the best of my knowledge, this is what I did. And a lot of this was done in a Panera, by the way. Panera is a good place to work on your talk and do Python. So I installed Anaconda with Python 3. I launched the Jupyter Notebook and created a notebook project. I forgot to fix my typo. And I tried to host my project online because I thought maybe this would work a little bit better if I went with somebody professional like Microsoft that had already set up an environment. And it actually worked out pretty well. I was having a good time with that, and I got some ideas out of how they had things set up. But then I decided I needed to move it back down to a laptop so I could present at the conference, because I was going to need to run the Jupyter kernel on a Mac so that I could do some of the things that I wanted to show you, right? Because I can't use whatever Linux virtual machine that Azure had spun up for me to do things that required a Mac. I I needed to finish setting up Azure, so I created an environment to install modules to, and I captured that environment so that I could reuse it, because I knew that I was going to want to come back down to a computer at some point. And then a lot of stuff happened. I was like working on different things, trying to figure out how Jupyter Notebook worked, and and eventually I got really frustrated and deleted everything, except for my notebook and the environment YAML file. I kept those and I downloaded them. So I took those and I reinstalled Anaconda on my device, and I copied that Jupyter Notebook and environment YAML into a place where I could use them. And step 3 is a lot, I know, but I created a local environment, ran it, launched Jupyter again. And to do that, I ran that conda environment list command, found out what environments I had on my computer. There were none at that point. I activated Anaconda 3_501, which is the environment name. It's just a name, doesn't mean anything else. I tried to reuse that name on my local system. But it gives me a warning like, oh, I didn't set up my shell, so I had to go set up my shell. So I did conda init ZSH, because I've been running ZSH for years and years before it was fashionable, and I can't say I've done anything with it that wasn't, I mostly tried out all the different plugin things and found out they were really slow. So maybe you'll have better experience with that. But because it updated my ZSH config files, I had to source them. And so I ran the source command, and then I was able to conda activate the environment name, and that worked perfectly fine. And in the same command, just because I wanted to keep running that with up arrow as I was trying to make things work, I ran a .command file that they provide with the Anaconda distribution. It's right in the Anaconda binary directory. And that's the Jupyter Mac command. And that starts up the Jupyter server, and it actually opens up a web page in your browser, does a redirect, and then gets you to basically like a file browser with some of the Jupyter interface around it. And from there, you can click on whichever notebook file you want to run through the notebook server. So things worked a lot better when I did that. And I felt like I was eventually going to be able to reproduce it, once I remembered what the commands were. So as I was going through and working on this, I was doing a lot of research and listening to podcasts, things like that, like lurking on the Python channel in MacAdmin Slack, and seeing what people were doing. And I wanted to give you a list of the tools that I was looking at for this talk, things to help with code. And there's going to be some links in here, and the links will be in the notes when they are made available by Penn State. And they will get them when I figure out how to export them. But if nothing else, I will have a link to the Jupyter Notebook at the end. And I did not want you to see all the fun bits ahead of time. So it really just says Impractical Python right now, but that URL will be at the end so that you will be able to see the Jupyter Notebook. And it will be at Azure, the Azure Notebook service, so you could potentially make an account and run that notebook yourself, assuming you want to go through this experience again. So Microsoft also has some interesting things going on with Visual Studio Code. Python is their #1 program, or #1 plugin rather, for the entire VS Code product. And they, I think, are really proud about that. And I've come to find out that Python has quite a few of the Python core developers employed at the company. They're doing a lot with Python. They've even brought Python into the Windows App Store. Imagine that. Imagine if we had Python in the App Store. But VS Code is getting a pretty good reputation amongst Python developers, from what I can tell. It was actually in the JetBrains survey, and I think it was the #2 editor behind PyCharm. And a lot of people seem to be using it. It does have some really interesting autocomplete and IntelliSense, specifically for Python. And in one of the interviews with a PM from that helped make that tool. I heard that uses machine learning, so that's a good buzzword there. And they also have that IntelliSense module available separately as a Python language server that you can run in any editor that supports the language server protocol, which is something I did quite a bit of reading about, and I still haven't quite figured out where else to run it, but it looks like it's new enough that editors will be probably starting to adopt it because it gives an editor agnostic framework for adding in tools like this. It also supports linting, testing, and debugging, so it's got a lot of the features you might want in your full development cycle. I also came across Cookie Cutter, which is a command line tool, and it creates projects from templates. Has anybody seen Cookie Cutter before, by any chance? Yeah, I mean, when I heard about it, it was on a podcast where they seemed to think that everybody knew about it, and I thought, well, this sounds like the greatest thing. And I'm not really sure what I would use it for. I kept looking, for something I could demo, and it finally hit me after it was too late. Like one of the main things I could have tried was Monkey Package. What if you set up Monkey Package, with a cookie cutter? But you're basically using Jinja templates like you might use for web development to set up some boilerplate stuff in a template, and being able to duplicate that. It'll ask you questions so you can fill in variables and output the skeleton of your particular project, whatever it is. And there are a lot of cookie cutter templates. I did not see any that specifically applied to Mac administration, so if you are into that kind of thing, it's probably a good thing to set up. Maybe make your own. And here's how you would run it. I shelled out for this, and because I've run this multiple times, you now see that I've run it multiple times, and the cookie cutter I used is already present. But you just run the cookie cutter command after you've installed cookie cutter, and then you can give it a path to a template file, a template archive. And in this case, I'm using an HTTP URL to GitHub, and this will just help you make a Python package. So it's just one of the examples that they have. So since it's written in Python, it's kind of natural that you'd want to make a Python package with it. But they support all sorts of other kinds of packages for different languages, different situations. I thought it was pretty neat. A lot of times we take our Python code and put it in Git, and I wanted to point out there's a couple of pre-commit hooks that may be of interest to us. So again, these links will be in the session notes. The MacAdmins link goes to Elliot Jordan's archive of pre-commit hooks. I believe he talked about what he's doing with those kinds of things earlier in the week, and it sounds really, really interesting. And there's also a large selection of other pre-commit hooks that you can use for different kinds of projects. That link takes you to a project page where they list, I think it's hundreds. It's pretty amazing. So if you don't want to write your own Git commit hooks, and I don't blame you because I don't think I've ever written one myself, this would be a way to kind of get easier way into that and have something set up for you. I also found Black. Black is the uncompromising Python code formatter. It's supposed to generate code take your code and reformat it so that it looks the same regardless of what kind of project you're working on. And by doing that, it's going to eliminate extraneous things like lines and spaces and whatnot that would normally mess up diffs when you are trying to diff between files for different versions. So that's certainly something to look at. I've seen people talk about that in the Python channel on MacAdmin Slack. Just a special note, let me remember my keystroke to go back. Black only runs in Python 3, but if you have Python 3 installed to run it, you can use it to format Python 2 code. MyPy, this is a tool I actually haven't used because I don't particularly have the need for it yet, but if you're working on a bigger project or you happen to be working on some web stuff maybe, It can help you with some of the features in Python related to type checking and making sure you're not trying to combine different kinds of objects of different types, like strings and, well, strings combine with a lot of things, so I don't know. A dict and a string, a dictionary and a string. So one of the interesting things about this is that Python 3 also adds type hinting, which is something that it sounds like it's kind of controversial that not a lot of people seem to want it at first, but I think it's getting some popularity as time goes by. It's only in Python 3.5 or 3.6, I think. It's relatively recent, and that helps give your code some hints about what kinds of objects, like a function or something like that, will return. And this can help troubleshoot those things. But one of the things I do use is an editor config file. I don't know, does anybody else use an editor config file? Okay, that's good new information then. So you can put code style into an editor config file. It is a .editor config file, and it's understood by a lot of different text editors and code editors. And it's a kind of a simple concept, but I think it's pretty cool. It lets you set up your indentation style, like tabs versus spaces, because whether we have a preference for one or the other, you may need to use the opposite in certain cases. Like I normally use spaces, but I think I use tabs in property lists, for example. Indentation size, that would be the number of tabs or spaces, line endings, things like that. So I'm going to use that with a configuration file. We're going to get into the files here. So this is an editor config file. This is a very basic one. I think I probably started this off, getting it from somebody on the web. And it starts off with root equals true, which basically stops your editor from looking for any other editor config file in a directory farther up, because you can have editor configs that kind of composite together to give you different settings. But I basically use one at the top level of my documents folder. And in this case, I'm setting up Unix-style noon lines at the end of every file. I'm setting up spaces for my indent style, 4 spaces for an indent, ending a file with, or ending a line with a line feed, and trim the trailing white space. So like if you ever have invisibles turned on in your editor and you see like spaces at the end of a line, this will eliminate that. I kind of like that. So in order to work with this file in Python, as an example, because it was the easiest config file I could find, I use the config parser module. I'm also using the pathlib module, which is a new module in Python 3. If you've ever used OS path in Python 2, that is more or less superseded by the pathlib module. OS path is still there, but pathlib gives you some other capabilities, and it's not as big a namespace as the OS module, so it's less to import. Setting up an editor config object using config parser. I'm going to be working with this. So I get the editor config file, I set the path of it as a variable, and this is going to be in a resources folder right next to my Jupyter notebook. So that will be up in Azure later. And I'm going to read that editor config file, and I'm going to run this again, because if you notice right next to the code, it says in and brackets, and this means that because there's no number in the middle of those brackets, this has not been executed yet. So I forgot to re-execute it before. So now I'm getting an error. It's probably because I didn't import things back. Let me go back. Let me go back and import all of these. Okay, so I got those things executed. And I'm now going to rerun this, and it should clear up my error. So it didn't clear it up for you because things don't happen over here automatically. Sorry, you're watching me not do anything up here, and I'm doing things on my screen. The presenter view is a little annoying. So I just went through and reran the last couple of lines of code, and in the result I get an asterisk in quotes. And that's because the first section in that INI file with an asterisk in square brackets. Now the reason why I created this file ahead of time, and I'm not creating it completely with Python to demonstrate how config parser works, is that this particular section is not valid as far as config parser is concerned. But I did find that if I read in a file, I could append to it later. So that's what we're going to do. So with this, I'm going to add to the editor config object. I'm going to add it's basically a glob pattern for star.js py plist mobile config recipe. So this will cover everything like JavaScript files, Python files, property lists, configuration profiles, and recipes from auto package. I'm going to tell the editor config that I want those to always be UTF-8. So I don't have to choose what kind of text I'm using. And you remember that notebook changed dialog that we saw a little while ago? I just got that again over here. The funny thing is you'll get it on either the presenter display or the slide display. It'll go back and forth. I haven't figured out, and it only started appearing in the last day, so I haven't had time to Google for that one. So with this editor config line, I'm going to run it. Okay. And go on to the next thing. And I have a path for a new editor config file, again in that same resources folder. And in this case, I'm using pathlib to check to see if that file exists. And if it does exist, I'm going to remove it using the OS remove method. So the capital P path is a path object, and the path is a string with the path name in it. And then I'm using the exists method on that object to see if the file exists. So it's a little bit different. It took me a while to figure that out. I think I'm starting to get the hang of pathlib, but it was a little bit confusing at first. So once I delete that file, if it already exists, because I want to make it fresh, for demo purposes, then I'm going to open up the new editor config file, get it ready a file handle for writing, and then I'm going to write the current editor config object to that new file. So if I do that, I'm going to do it over here for you. So let me make sure I run this again too. All right. And now I'm going to print out the results of that. So you can already see what I have. So this was executed previously, but I will re-execute it for you. And you see the same results. So I've got the original editor config file that had the asterisk section, and now I've got the new section that I just added in with the new glob patterns. Those glob patterns will match files on disk and that are being read in your text or code editor. I'm going to add something else on. I'm going to add something specific to Python. I've already matched against Python, but I can match against it again in my editor config. And I'm going to tell that anything that's got .py in its name is going to be a Python file. I'm going to use mode Python, and that gives a clue to whatever text or code editor that I'm using, that I'm editing a Python file, and it can do the right syntax, coloring, and all that kind of stuff. And then I'm going to open up the editor config file again, the new editor config file, and I'm going to write the additional information to it. I'm basically writing the whole object back to it each time. And that I'm going to print that out, and I get the same thing, but with the added set of lines. So I'm going to get the star.py mode equals Python. So you can do this. I'm not going to keep going on with every language, although I have that in my main editor config file, pretty much everything that I use. If you really want to see that, I can show it to you later or send it to you. But I suggest, since a lot of you didn't raise your hands on editor config, if you do any coding, this is a worthwhile thing to set up. And it does let you move between text or code editors pretty nicely. So almost every editor I've found has a way to load it in, even though it may be a module or an add-on. Like in VS Code, I believe it's an add-on. They kind of have an app store for it. All right, so move on to dealing with just regular files and finding out what they are. We've all run the file command and had fun finding out that a PDF was a PDF. I think it's like can do that in the first month with Mac OS or any Unix. But Python has a module for that as well. So I thought I'd try that out, since I'm not trying to limit myself to the standard library in this talk. And I wanted to import that magic module, but it turns out that I had to install install a library at the system level for that, because the magic module is not bound to the right stuff in Mac OS in order to do this right out of the box. So I happen to have Mac ports installed, and so I used Mac ports to do this. I had to update the list of ports, and so this would be the same sort of thing if you were using Homebrew or something of that sort. And I had to go through and install, in this case I had to install file, because that's where I got libmagic. Libmagic is the special thing I needed to make this all work in Python on Mac OS. I wouldn't have needed to do this on another Unix if I remember correctly. So that's all the output I got while I was doing that. And then I was able to run magic from file, and I picked out a shell script that is in my Jupyter Notebook. This is actually the Azure Notebook setup script. It was one of the things I was using to set up the environment on Azure, and it comes back and tells me that this is a POSIX shell script. Okay, that's cool. So I'm going to get pathlib again and do something with it. So I set up a list of files. Most of these files are in the OS or in applications that come from Apple, like Keynote, and applications that may not come from Apple anymore, like iTunes. And I'm just going to run through those and show you what magic does on this. And I'm doing this with the pathlib module to not make it like running type, or not running like the file command in the shell. So I'm going to set up a list comprehension for magic test paths, where I'm going to say, it's basically the construct here, if you haven't used a list comprehension, is x for x in something. So in this case, I'm getting the path object of x, and I'm doing expand user on it, because some of my paths have a tilde in it for the user's home directory, because I didn't know where I was going to be running this. So, and if you want to run this on your device, it'll get your home directory, because I put tilde in it. But I needed to expand that to actually work with the full path. So I got that as my first object, and then I'm looping over that. And I'm looping over the magic test files. So I'm getting every item in the magic test files array. And I'm only getting those files if the path of x, when I expand it, so that it takes out the tilde and puts in the absolute path. I'm only doing that if that path exists. So I'm using that capability in pathlib again. And so just to show you what that does, I printed that out, and instead of just getting a bunch of strings, I actually get POSIX path objects. So that's one of the objects that you get from the pathlib module. So I'm going to take that, and I'm going to make a table, because I figured out how to do that in Jupyter Notebook. And I'm going to do that by giving a file path, a file name, and a file type header row. And then I'm going to go through all of the paths in that array of POSIX paths, and I'm going to get some information out of them. So the main thing that I'm doing is getting this file magic. That's where I'm running magic from file on the path. And I'm going to eventually end up appending that all together so I can make a table. So let's look at that table. So you love how big that text is? So this just produced a table, and I'm doing that by importing a tabulate module. Again, not limiting myself to the standard library. And the tabulate module lets me create a table in HTML, and I use that with a built-in display method in Jupyter Notebook to display that HTML. So this is kind of like the Python is outputting HTML, and then another bit of Python is rendering that in Jupyter Notebook. So it's kind of weird. But it shows some of the capabilities you can get. And I guess this is what going to scientific conferences is like. So we have yet another markup language, literally, and YAML is used for a lot of things. I've seen it in various places in different administration products or cross-platform software that you might need to manage on a Mac. So it's good to be able to do something with YAML. So I'm gonna do something with it, and to make that happen, I'm gonna import the YAML module, which is something I had to add on to Python, I think. I'm also importing the pretty print module. And if you haven't used that, it lets you pretty print the output of things, especially things you want to have indented. So I'm going to use that. I'm going to set up pretty print to indent 4 spaces. And notice that this is not in quotes. This 4 is not in quotes. It's an integer here. If you happen to put it in quotes, it becomes a string. And then your indenting becomes a series of the number 4. I'm not telling you this because I had experience with that. Honestly, I did, of course. That's the joke. But I thought it was just something that Jupyter Notebook was doing to me at first. Like, what's going on here? And finally, I realized it was the quotes. I had talked earlier about having the Anaconda environments. Well, I have an environment.yaml file that I've passed to Conda in order to create the environment, the Python environment to run this whole notebook thing in. And so I'm going to take that as a path object, that environment.yaml file. It's in the same directory as my Jupyter Notebook. I'm going to open that up. I'm going to set that file handler to F, and I'm going to use that to feed the file path over to YAML load. So having a .load method is a pretty common way of dealing with loading in data to Python so that it can be used. I found this construction and a lot of other modules, including one we'll be showing in a few moments. So YAML load does this, and it just brings the YAML into Python so I can do something else with it. In the case of YAML, though, I started getting exceptions partway through, where it was telling me that there was a problem loading YAML, because apparently you can somehow get YAML to execute, somehow, I don't know. And I put the URL for you if you really want it. But I had to put this loader attribute on the method in order to get rid of that warning. So if I check the type of that YAML data object, it's a dictionary object. So that's good. That brought the YAML right in, and instead of YAML, which is a text file sitting on my disk, I now have a dictionary that I can manipulate in Python. More drinking. So having a native data type is nice. So I'll pretty print that YAML data so you can see what it looks like. So in this YAML file, I have some channels. That's kind of like a catalog of where I'm getting Python modules from. In this case, I'm getting them from Conda, Forge, and defaults. And then I have a whole bunch of dependencies. So those are things that are going to be installed, like pip and setup tools and Jupyter. Some of these things are already installed, but I'm just loading them for good measure. And because it's a Python dictionary, I can look into that dictionary and just see one of the keys, just get the dependencies key, and I can print out all of its values. So I've reached in, gotten one piece of the data out. So that's fairly standard for Python, working with dictionaries. But I wanted to go a little bit of a step further with working with files. So I thought we have to use CSV from time to time. That's a pretty common format. So I was trying to make a CSV file that had some fake data in it, rather than like exporting something from a production JSS or something of that sort. And I found this module called Faker. I thought that was awesome. There's a whole module just dedicated to generating fake data. I mean, if there's nothing else that you get in this conference, you can generate fake data back at your job. So For the life of me, I could not get this module to import correctly in Jupyter Notebook. I don't know what the problem was. This was actually what led me off of Azure and back to a Mac. But Faker was not working. But I thought, there's got to be some way I can do this. So I just went the low-tech way and used its command line tool. It has a CVS Faker tool. And the syntax for this is kind of neat. I'm generating 100 rows of data. And I've got a first name, a last name, a job title, latitude and longitude. I mean, this can generate lots of stuff. A date this year. There's all sorts of different dates you can generate, but I just picked one for this year. A Mac platform token. You could generate user agent strings if you want to, things like that. A MAC address and an IPv4 address, because clearly these are pieces of information that would always be in the same data file. And I just doing this in the shell, so I wrote it out to this resources random CSV file. And I've just left that in my Jupyter Notebook, so I could reuse it over and over, so I'm not regenerating it each time. I couldn't regenerate it because if you notice, Natasha is the first record. Too soon. So I'm reading in that text file by getting the CSV data, getting a path object for that file, and pathlib has a really, really neat method that I came across called read text. And this collapses down a lot of file reading operations by maybe 2 or 3 lines, depending on what you're doing. So I really like this. And so I used read text, and then I split on the new line character. So that's one line that takes a file object, reads every line in it, and splits the lines up so that they're individual entries in an array in Python. So then just to have this for the next slide, I took the length of that CSV data. The CSV data is an array, so I'm getting the number of items in the array. We'll see that in a moment. And to show you what was in the data, and you can see that the first record is for Natasha, and that was random. I did not do that. I'm printing out the CSV data, and I just printed out the first 5 records. That's a Python slice for, actually it's first 6 records, because I'm printing out 0 through 5. 1, 2, 3, 0, 1, 2, 3, 4, 5, because Python is 0-based. So next, I was thinking about using the CSV module that's a built-in module in the Python standard library, but I thought I'm not limiting myself to this, so I looked at Pandas. Pandas is one of the, probably like the big 3 modules for data analysis in Python. And so I imported that, and I gave it a name, PD, because that's what every tutorial says, and I'm just copying and pasting. And with that, I created a data frame, and that data frame is represented by df. That df variable is using pandas and a method called read CSV. So like in one line, it's reading the whole CSV and putting it into basically a matrix of data. I'm like, I was mind blown by that, really. What do they say at Apple? Blow away? That's blow away. I don't know. Anyway, so I got the length of that, that object as well, and then you can see that I printed those out. So the data frame from Pandas ends up being 100 lines, and the CSV file is 102 lines. I didn't go back to double check, but I know it has a header row, and I think it might have a blank line at the end. So that's why there's a discrepancy, but I just wanted to show you that, the CSV file is actually being read as a file. The data frame is just the data. So pretty neat. And we're going to do more with that. These all bleed in together. So Excel. Sometimes we have to take things into Excel. Managers often like that. Maybe it's Google Sheets for you. I don't know. But Excel. Let's do something with Excel. So I'm going to set up a path for an Excel file, and I'm going to open up that path as a file handler, and then I'm going to take that data frame, the df, and I'm going to use the toExcel method. I just wrote that to Excel. That became an Excel spreadsheet in like an instant. I thought that was pretty neat. Now, because I can shell out, we're gonna open up this file. I'm gonna do it over on this screen because this screen gives me more confidence in Excel. I'm gonna see, oh, it opens up on my main screen. It did this every time. Hold on, now I lost Excel. There we go. I'll drag this over for you. It's stopping. Hello? All right, I'm gonna mirror for a brief moment because this makes me sad that you won't get to see this Excel document. Because this is the highlight of the show. So there's the Excel document. So also in tiny text, I apologize about that. Now we'll see if Pandas and Jupyter Notebook and all these windows survived going back this way. Of course it didn't. Everything's on my main display again. The goggles, they do nothing. Ooh. There we go. All right, so back in the presentation, we've opened the Excel file. Now we have JSON, JavaScript object notation. This is commonly used in JavaScript. I don't know JavaScript, but I see this stuff all over the place. I think I've ended up using it in Puppet and some other places where it's needed for data. So I'm going to set up a path to put some JSON data in, and I'm going to take this data frame, and then I'm going to use the toJSON method. Boom, I just wrote that same data frame, that matrix of data, to JSON in one command. I love this stuff. Like, I wish I'd known about this before. And I'm using that JSON path, and I'm orienting it as records, which puts like every line together in its own, block of JSON. So it's like a dictionary of JSON an array of JSON with individual dictionaries for each record, each row of the original CSV file. So just to show you how that works out, here I'm just shelling out and using the head command and getting the first 72 characters because I don't want to go forever. And you can see we get Natasha again. So since we don't have header rows and things in JSON, we're just getting the data frame from Pandas, we're just getting the record, and she had the first record. So now I'm going to use the JSON module in Python. I'm going to open a path up for that as to read it, and I'm going to use the load method on the JSON module. So just like with the YAML, we're going to do JSON load. And you have no idea how many dialogues I'm dismissing as we go along. So the new JSON path, I'm gonna make a new path for JSON, and I'm gonna change the original JSON data that we got. And so I'm gonna open up that new file with a write file handler, and I'm gonna use the JSON dump method. It's what they called it. I didn't choose the name. This is also very common. There's a YAML dump and all those kinds of things. So I'm going to write the JSON data that I got in the previous step. I'm going to write it out to this new JSON file, the JSON out path, and I'm going to indent it for, and this time I learned my lesson and I didn't put quotes around the for. It probably would have given me the same problem. And so here I'm using the head command to just get the beginning of the new JSON file, and you can see that it's formatted differently. The last one had everything smushed together in one line. This time it's pretty printed, indented, four spaces in, all that kind of thing. So you can use this to even just change how your data is represented on disk if you want to. So then we talked about that spreadsheet. We talked about that survey. I gave you the QR code, the URL. Some of you did it. I saw a lot of people taking pictures of the QR code. I'm assuming it was a QR code. I wasn't looking really great at that moment, so you probably didn't want a picture of me. But the back end for that is a Google Sheet. So what if we could access that Google Sheet in Python? So I've found there's a Google Spreadsheet module that lets me access Google Spreadsheets. And in order to access them, I need to authenticate. So this is using OAuth 2. It's an OAuth 2 client for doing authentication with any OAuth endpoint. There's probably some special name. Somebody know what you authenticate to in OAuth? Okay. I'm not alone then. Of course I'm not alone, and I'm in a huge room with a small number of people. So to get this all set up, again, I was copying and pasting off of a web page, as we all do. And I set up the scope for accessing this particular spreadsheet. And I set up some credentials, which I pull out of a JSON file that I got when I set up credentials in Google Sheets and their developer API portal thing. It had a special name. And then I'm setting up a client object that I'm using to authorize my access to that Google spreadsheet. And then here's where everything fell apart. So just to spoil the punchline, I didn't get this to work. I'm sorry. But we can still go look at the results. I think they're pretty cool. And we have 14 minutes left. So I really didn't know what to do for the Google Sheet name. And I really wanted this to work, but I tried a bunch of things. I couldn't get it to work. I basically got the same error every time. So I'm leaving the errors here because this is what working in Jupyter Notebook was like for a lot of my time. So there was a lot of troubleshooting. But I did get through it, and for the most part, you didn't see any other errors in this talk, so I feel kind of good about that. But if anybody, after the conference, during the conference, whenever, in 90 years, if you figure out how to do this, feel free to let me know how to make it work. So eventually, as I said, my Jupyter Notebook will be up at Azure Notebooks. I'm doing it just because it's kind of like the GitHub for Azure Notebooks, or for Jupyter Notebooks, or at least it's one of them. There's quite a few others, but this is the one that I tried. So it's notebooks.azure.com. It's a free service. You need a Microsoft account, your Hotmail account, your Live account, your Outlook account, I don't know what the domains are they're using anymore. But one of those, and it's at Jaharmi Projects, PSU MacAdmins 2019-Python. I should be drinking water every time a dialogue comes up on my presenter screen, and then spilling it on me. So we have now reached the point for questions. I know you are all following along avidly, and you probably have some questions about things that I didn't explain very well and wasn't clear about. Do we have any of those questions? If nobody says anything, I'm just going to throw the call box at somebody, and you're going to have to say something.
What is PyJokes?
You need to speak into the box. It's on. Matt told me it was on.
What is PyJokes?
What is PyJokes? PyJokes is an actual module. You can import it. You can pip install it. I think you can get it via Conda and the Conda Forge as well. It's an honest to goodness open source Python module for spitting out jokes. So it's kind of like something Tim Perfit would make, but running in Python. Any other questions? All right. Thank you very much for all of you for attending today. I really appreciate you coming out and taking a look at this crazy scheme that I worked on to try to find out how to do some work with data in Python and do it in Jupyter Notebook. It was definitely a learning experience for me, and I hope if you have data to analyze that you do try to take a look at it. I think you'll have a much better experience if you're doing it and not trying to also make a presentation with it. Don't make that your first project. So I really do appreciate the Jupyter Notebook software as well. It is really neat, and as I was doing these things, I was really wishing that I could do these kinds of things in Keynote as well. Like if I could just take an object that was like a terminal and be able to run things live. I thought that there's a lot of neat concepts in this, and that's the way I'll leave it. The feedback for this session is at this link. Sorry, I didn't generate a fancy QR code for that. But I'd love to hear your feedback on this, but I will only accept the highest ratings. And I'd also, at this point, like to thank PSU for running another great conference. I really appreciate the chance to come and see the things that all of you are working on and take part in the hallway track and things like that. So, thank you.